Many people hear the word quantum and immediately think of science fiction. They see it as a technology always 10 years away, stuck in university labs and theoretical whiteboards. Skeptics say it's delivered little practical value to the average person or business. They ask, where are the results? Where is the proof? As of today, December 28, 2025, we have a concrete fact-based answer. Quantum-inspired innovation is a present-day reality, producing measurable change across the economy. The proof isn't one single dramatic breakthrough that solves everything. The proof is a convergence of critical advancements happening simultaneously. Record-breaking financial investment, significant hardware milestones tackling fundamental engineering challenges, the birth of powerful hybrid systems combining quantum insights with artificial intelligence, the deployment of quantum-inspired tools in major industries. These are not speculative forecasts. These are documented events from 2025, backed by numbers and company names. Before we dive into the evidence, it is crucial to establish a clear and simple definition of a key term: quantum-inspired. This phrase can be confusing. It covers a range of technologies. Not all require a physical quantum computer. At its core, quantum-inspired means method algorithm piece of hardware that leverage quantum principles to solve hard computational problems. These approaches change how we process information, producing faster or more accurate results than classical-only methods. The most direct application is actual quantum hardware. Companies like Quantinuum IBM are building processors that use quantum bits, qubits. They use the principle of superposition entanglement to explore many possibilities at once. One of the most telling indicators of a technology's transition from theory to commercial reality is the flow of capital. In 2025, the financial world has placed an immense vote of confidence in the quantum industry. According to Network World, quantum computing companies raised a staggering $3.77 billion in equity funding in just the first 9 months of this year. To put that figure in perspective, it is nearly triple the $1.3 billion that was raised during the entirety of 2024. This dramatic acceleration signals that sophisticated investors, venture capitalists, corporate funds, they are no longer betting on a distant dream. They are funding the scale-up of a burgeoning industry. For instance, PsiQuantum secured an incredible $1 billion in a single funding round, making it the world's most funded quantum startup. Similarly, Quantinuum saw its valuation soar to $10 billion after its latest funding round brought total capital raised to $800 million. As Quantinuum noted, this funding enables them to accelerate development of the world's first universal fault-tolerant quantum computers. These are not small, speculative bets. They are strategic investments on a massive scale. The broader market data confirms this explosion of confidence. Market analysis firm SpinQ reported the global quantum computing market reached $1.8 billion to $3.5 billion in 2025. Projections show this market is expected to grow to $5.3 billion by 2029, expanding at a compound annual growth rate of 32.7%. This growth is not just based on future hopes, but is fueled by tangible progress. As one report from McKinsey stated, quantum computing companies are expected to surpass $1 billion in revenue in 2025, a significant jump from the $750 million generated in 2024. While investment is a crucial indicator, a technology is only as good as its underlying hardware. For years, the primary obstacle was building machines with enough stable qubits to do useful work. Qubits are fragile and prone to errors from environmental noise. In 2025, leading hardware developers made demonstrable progress on these engineering problems. They moved the tech from small-scale experiments to more powerful problem-solving machines. These aren't incremental tweaks, they're key milestones toward quantum advantage. A major headline: IBM unveiled its Nighthawk processor. The chip features 120 qubits, but the raw number isn't the main story. Crucially, the qubits are linked by 218 next-generation tunable couplers. Those couplers give much greater control and connectivity inside the processor. That architecture lets users run more complex algorithms. IBM projects it can handle up to 5,000 2-qubit gates. Enjoying this video? Please like and subscribe. IBM calls this a critical step toward quantum advantage by the end of 2026. Quantum advantage, solving a real-world problem significantly better than any classical computer. At the same time, Google's quantum AI announced a landmark in the fight against errors. Google's Willow processor, about 100 qubits. They demonstrated quantum error correction operating below threshold, meaning adding more qubits to the error correction code reduces overall error rate. This proves at this scale that a self-correcting, fault-tolerant quantum computer is physically achievable. Hardware gains are matched by control system breakthroughs. University of Colorado developed a microchip-sized device to control laser frequencies with extreme precision, and it uses far less power than current systems. Dr. Friedman: we're getting close to a truly scalable photonic platform capable of controlling very large numbers of qubits. Perhaps the most exciting development in 2025 is the practical convergence of two of the most powerful technologies of our time: quantum computing, artificial intelligence. For years, experts have theorized that these two fields could amplify each other, but this year we saw the first commercial frameworks designed to make this synergy a reality. This hybrid approach, where the unique capabilities of quantum processors are used to enhance classical AI models, is already opening up new frontiers in problem-solving and has become a major focus for industry leaders. It is a prime example of how quantum-inspired thinking is creating immediate value. The most prominent breakthrough in this area came from Quantinuum, which announced its groundbreaking generative quantum AI framework, or Gen QAI. The core idea is to use their powerful H2 quantum computer to generate unique datasets that would be incredibly difficult, if not impossible, for a classical computer to produce. This quantum-generated data is then used to train classical AI systems. According to Quantinuum, this process can significantly enhance the fidelity of AI models, allowing them to tackle challenges previously deemed unsolvable. This quantum AI synergy also holds the promise of addressing one of AI's biggest growing pains: its enormous energy consumption. For any technology to be considered a win, it must eventually move beyond research and development and generate real economic value. In 2025, quantum-inspired methods have firmly crossed this threshold. The United Nations designated 2025 as the International Year of Quantum Science and Technology. According to a recent McKinsey report, quantum computing companies are on track to generate over $1 billion in revenue in 2025. This revenue is not coming from government research grants alone, but from growth in deployment across private industry and the defense sector. Businesses are now paying for access to quantum systems and for consulting services to apply quantum-inspired algorithms to specific challenges. Early adopters are already seeing a return on their investment, whether through improved efficiency, new discoveries, or a competitive edge. The application spans several key sectors. Pharmaceuticals, life sciences companies are using quantum-inspired molecular simulations to accelerate the drug discovery pipeline. By modeling complex molecules more accurately than classical computers can, they can identify promising candidates faster and at lower cost. While much of the public focus has been on quantum computing, another branch of quantum technology has been quietly maturing and is already being deployed in the field: quantum sensing. These devices leverage the extreme sensitivity of quantum states to measure physical quantities like time motion, magnetic fields with unprecedented precision. Unlike universal quantum computers, which still face years of development, many quantum sensors are already robust and practical, delivering capabilities not possible with classical technology. One of the most compelling use cases is navigation. The evidence from 2025 paints a clear and compelling picture. The debate over whether quantum-inspired technology can deliver real-world value is, for all practical purposes, over. The question is no longer if, but how fast and in which areas. Together, provide an irrefutable case that we have entered a new era. This does not mean the journey is complete. Are valuable innovations solving real problems today? The proof is no longer in the promise, it is in the performance.